So I don't know if you noticed, but the solutions for the exercises, just scroll down and you'll get a little more, you'll get a working solution to showing things. Look at the rural postcode in BC. And when you do this, maybe I'll just try it now. Did I do that right? No, now I am. You'll find that like most provinces, the first like 10 postal codes is almost the entire province. Look how long it takes to render. I've got simplified shapes turned off, but rendering on a BC data set is expensive. Eventually it comes back. But, and you can see why. All those little dark lines there, those are all shapes that have to be drawn and then overlaid with the data. But you can see, anyway, the whole province is almost entirely rural. Doesn't even respond well. We're down here at the bottom. We'll zoom in. I know where the UVic is. I couldn't identify U Manitoba. But there it is. That circle there is the ring road. Used to be a, was it an Air Force base? Used to be some kind of base. Right, and that's the Hinch building. Is that it right there? We're in this building, HSD here. Is that you should realize this by now that programming is a skill. It's not really so much knowledge anymore. You need to have some framework of knowledge, but the itty bitty details, you can get those as and when. Skills, of course, require practice, and with practice comes confidence. And perishable skills are, I changed that. I didn't mean it to sound like Yoda. But skills are perishable, and if you, it's a bit like I have my R skills personally are completely perishable. Every time I go back to R, I have to relearn it, and yet other things like Python comes back quickly, R doesn't. So whatever toolkit you choose, practice it and keep up the practice. Otherwise, you will lose those skills, and grow the skills. Try to push yourself every time. You want to do some novel work, you're going to need to stretch your skills. Okay, handling large data. This is the next topic, and straight back into the notebook. I have no slides for handling large data because we've talked about all the theory that we really need. So handling large data is the next one. I'll hide that. So no new libraries. We're gonna stay the course right now. We're going to reload everything. Every time you load a new notebook, it has no knowledge of what's in other notebooks. Okay, they're self-contained. So you need to import again. And depending on what else your machine is doing, it may take a little longer. Don't forget, this output notebook needs to be there as well. And as soon as it looks like it is done, that's fine. Right, so we're going to introduce a new data set. Now, I tried really hard to find COVID data for Manitoba. I found some, and for BC, I also found some at the BC CDC. Manitoba came from somewhere else, a government site, I think, but they had no postcode data. Okay, what I really wanted was something showing me the cases and something to do with the postcode. I'm not expecting to find individual people's postal codes. That's that would be a breach of various HIPAA laws. But I was able to find a data set for Ontario that had what I needed. Instead of the postal code for the individual case, it returned the postal code of the place where the case was detected. So the little health zone. Okay, and that maps really well with our FSAs. So I'm going to load that. This is from 2021, I believe. I don't know how up to date it is. I didn't re-download it. It's been here for a little while. And so we did that, pd pandas.read CSV. It's a CSV file. Now notice this, okay? All I gave it was the file name, okay? You can go look at the file, it's there, it's in your document tree. All right, but I'm not saying what the headers are or anything, I'm just loading it, okay? What do I get? Type, right? And we did type on foo in quotation marks, it returns string, or type with the square brackets, we got a list. What's COVID? It's a data frame right off the bat, because really a CSV file, especially if it has many values and rows all conforming to the same structure, it's a data table. Okay, and so COVID gives, Pandas makes a data table out of it, which is great, data frame, sorry. So pandas, now remember, I don't exactly know how many rows in here. We'll find out in a second. But when we did the postal codes, you recall that we tried, I warned you not to, I hope no one did it, but don't print it. Because if you do, it's going to try to print all 7 million entries, which it won't crash your computer. It'll just tie it up for a while. So pandas and the other associated tools that deal with larger data sets, they know their data is too big to dump to the screen. So they all have shortcut methods to summarize things. We're going to go through a couple of those now. First off, COVID.shape. What shape is this data frame? It's a funny word. What does it mean? It means that it has 500,000 rows and 18 columns. That's it. Not terribly complicated. And notice it's not a method. It's a property of the data frame. We don't have these, we're not calling it as a function. Okay. And it returns that. So that's good. And now here, print COVID, like, uh-oh, there's 500,000 rows, right? But don't worry, the data frame knows. Okay. And it's ugly, what comes up, because I don't have, maybe I'll maximize this. No, it doesn't help. Never mind. But what we're getting here is this block here is the first, the index, and then 1, 2, 3, 4 columns, okay? And this is the first row of those 4 columns, the first 4 columns. And this is the very last row of the first 4 columns. And you can tell it's the first 4 because of this little slash here, okay? And that it's supposed to suggest to you that it continues, okay? In fact, it does. And you notice that when we get to the end, the very last thing, okay, there's no slash, okay? So this reporting PHU longitude is the very last column, okay, which is fine. Now, what I really like about this data set and why it's useful for this is that it's got our postal codes, okay? And there they are, okay? So it's ugly, right? Because this has a lot of columns, okay? But printing it doesn't swamp your machine. It's only showing you the head and the tail of everything, and it's grouping it. It's like paginating it for you, okay? That's really useful. It means I can quickly get an idea of what's in here. There's also all kinds of data in there, okay? You get a flavor of what it is. There's more than one way to do it. Another way to do it, especially in the notebook, is call head on it. Head is a method. Think of a method as a function, but it really belongs to an object. Okay, so we call it a method. But think of it as a function. It's the same idea. COVID.head, if I run that, shift enter, I get a table. I'm holding down the shift key while I scroll. You do what you need to do. It's nice. It gives you the head, the first 5 things, and it displays you, in a way that's useful. More useful, actually, than just plain printing it, like we did up here. Okay, so useful. Just like you do in RStudio, it's actually very similar. I can do the tail as well. It'll give you the last 3 rows. Because I put in 3, I get the last 3 rows. I don't have to accept the default 5. Same deal. Again, there's our postal codes. Okay. We can, instead, we know all these rows here. There's age group, see age _ group. I can go and ask the data frame, give me this column. Okay, age group. Shift enter to run that. And again, it's not going to show me 500,000 rows. It gives me the head, 3 dots, and the tail, okay, with a bit of metadata. Repeats the name, shows you the actual length, and what is it, okay, which is handy, okay. And these are strings, yeah, but they don't wrap in quotes. It's nice and easy to read. These are categories. Let's say I want to see 2 particular. It's noted as an object, but really what this comes out as is a series. Okay, not that it makes any difference. If I say COVID with 2 square brackets, and I pass in basically 1 square bracket followed by a list, I'm going to get a summary of those 2. Okay, but this is no longer a series, right? It's no longer, it's just a simple index list, okay? What type is it? Well, we have to ask type again, okay, and we'll do that. pandas.core.frame.dataframe. Okay, so interestingly, it's a smaller data frame, and that didn't take a long time to come out, right? I mean, I'll run it again, right? Shift enter, It's instantaneous, effectively, for 500,000 rows. Okay, so this has been super optimized. Okay, these methods are very, very fast. All right. In fact, I can, because it's a data frame, I can go and call shape on it. Okay, because this returns a data frame, the data frame also has methods and properties, and you can chain them together. Okay, so it's again 500,000 rows, 2 columns. No shock there. You can call the head on it just as you could, and you get, you know, a nice summary. COVID.outcome 1. I can ask for 1 column on its own. Okay, and here now it's a series. Each column in the data frame is a series, right? No longer a data frame. Okay, and we can even ask what's the type. It's a series. Okay, so there's lots of ways for you to chop up the data. Let's say this is 5 million rows instead of 500,000, right? This would work in Excel. You could load this in Excel and go to town on it. Do your visualizations in there. But let's say it expands, right? You can't use Excel. These things are much faster. When you got it in a data frame, notebook like this, you can start writing in notes and do your initial analysis. Okay, let's look at a single element outcome. The 0th element of outcome is resolved. So you can see it here, the outcomes of this data set, they either are resolved or they're fatal. Those are the ones we can see right now. Okay. Let's look at number 10. What type is it? It's the string. So it knows that these things are strings. We can tell they're strings because they're made of letters, right? And a summary for the column names, related metadata, you can do covid.info, and you get, this is a global summary, okay? It's telling you it's a data frame. There's your range index, 0 to 542467. Great. 18 total columns. Here they are, this time in a list, okay, of all the various columns that are there. Okay, memory usage is taking up, you know, less than 100 megabytes, which is good. Okay, you cannot meaningfully display millions of data points. Can't do it in Excel, but you can here in Python. That doesn't read very well. Yeah, in fact, no, sorry, it does. It reads just fine. You can't display millions of data points. You can visualize it maybe, but you can't do it as a list like this. They do it in movies, right? You see data streaming really slowly, right? They'll show a video in the next scene, you know, which takes far more data, whatever. Funny things, right? You can write code to dump the entire data frame row by row if you want to. It would take hours. There'd be no use case for it, but you could do it. Okay. Sorry, I'm a little confused here. There is another one. Okay. Fundamental data analysis. I believe we're going to skip that because we're moving to cursory data analysis. So let's open up this next one. Okay, so this data frame, handling large data was all about how do you accomplish handling vast amounts of data, summarize it quickly, have a look at what's in there, poke around, show the head, show the tail. How do you do that? We're going to do some brief analysis. This is hardly exhaustive analysis, but just have a quick peek at the data to see what's there. Okay, same deal. Run this again every time because it's a new environment. It spawns a brand new Python shell and runs all this code in that shell. So never mind the ... It just means that that's been done. If you see the little colorful thing, it means great. Okay, so clearly we're going to start doing a bit more plotting because we didn't load that in the last one. Okay, again, this notebook does not know about the data yet, so we have to load it again. Takes a little while to insert that. Nothing's changing here. So let's do some fundamental data analysis. And depending on what system you've got, the versions for the Jupyter Notebook was the previous version of this notebook software. The new thing to use is Jupyter Lab, and they keep changing the way things work. But generally, you can hit escape, for example. So if I do COVID's loaded, it's there, it's in, knows about it. COVID.capital S. If I do escape, is it escape? If I do tab, it's tab this time. I get specimen date. Now, it's smart enough to know what specimen date is. You can do shift tab and it'll give you information about it. It tells you that it's a series, and there's more documentation. This is all built into the notebook. Shift tab pops that up for you. Okay, I can do value counts, and I can click tab again. This time I don't get an explanation or a completion. I get a list of things I can do. I can do value counts, values, or var. Okay, I'm going to choose value counts. Okay, and I'm just going to comment that out. Alt / next to the right-hand shift key. Comments or uncomments. Yeah, very handy. A commented line is not a line. It doesn't exist. COVID.specimen dates.value counts, shift enter. Okay, now here, specimen date, there's a lot. There are 400 specimen dates lodged here. So this tells us that in 2021, what is that, April? Oh, I'm awful with dates, 12. There were 4,000 cases. Okay, on the 13th, there was another 4,000 and so on. That was the worst time in this data set. Okay, in January, February, we didn't have a whole lot. Okay, value counts is giving us this summary. It's not showing us the whole thing. 490 is too much to show on the screen. So again, you get the head and the tail. Useful, right? COVID.age group. This is everything now. So they're in the 20s, less than 20. It's not been sorted all the way up to 90 plus, and there's a tail of them that we don't know who, how old the patient was that was seen. Okay. Now the handy thing is that this is a data frame. I believe, whether it is or it isn't, it's plottable. Okay, you've got categories as like axis values, and you've got counts, right? So you just stick a plot on the end of it. COVID.agegroup.value counts, call that. The return will have a plot method, okay? And again, we're using the semicolon because we don't want to see the little extra bits of text there, right? Okay, this isn't rocket science, okay? You're gonna get a very quick plot, okay? Most cases are people in their 20s, apparently, according to this. You can verify that, you can see it right there. Okay, and these are people that showed up at various health authorities. If they were already in care, then maybe they don't show up. Okay. The other thing you can do is you can sort the data frame, sort values by age group and case reported data. Okay, and if we do that, we get it sorted first by age group, 20s, 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 all the way down to the unknowns. Okay. And again, it's only showing you a particular head and tail of it. Okay, but it's sorted by age group first, and then by case reported date. Okay, which is January, February, March, and so on. Okay, all the way up. The data here ends in June. Okay, so that's useful. You need to sort it quickly. You're not changing the data. You're just getting a little summary. Actually, I believe you are. The sort order has changed it. Anyway, fatalities. Let's make a new data frame using this one. Okay, by selecting only those rows whose outcome was fatal. Okay, if I scroll over here, where there's resolved there. Okay, the fatal doesn't show up here, but we know it exists. Okay, so if I do COVID and then in brackets, I am making a selection, or I'm filtering out only those where the value is true. Okay, if I do that, you're going to get only the ones that are fatal. Likewise, I can do it this way. I can take the fatalities and then extract the age group, get the value counts for that, and plot it. Okay, and right off the bat, you get this. If I put a semicolon at the end and run it again, the axis subplot disappears. Okay, so we can see that of the fatalities is a completely different story. Okay, it's the people who are elderly who have the highest fatalities, despite most of the cases being those people in their 20s. You can see it up here, right? Okay, details about flipping the axis and aligning it with others, those are just details. We're having a very quick look to see what we can do. Okay, here's another one. Do it by gender this time. What are the value counts for gender? Male, female, unspecified, and gender diverse. So they're not quite fully into the spectrum of identities in here, but you know, they've got something better than nothing. You want to look at just the, what am I doing here? Okay, so we can do that. Stick a dot plot on it if you want. You'll get a result. Oops. We're getting that this is it's a method. Actually run the plot. It's not particularly pretty. So, you know, it's fine. This is a notebook. Go and change it. Get rid of it. Run it again. Okay, and you get much more useful information that way. Keep what works. Throw out what doesn't. Or at least comment it out. Okay, there's things you can uncomment on your own time. And do it at your leisure. What's the type of COVID gender client 0? So we're looking at the client gender. That's this value. It's going to be a number. No, it's not. It's a string. Interesting. Okay, that's good to know because what we're going to do next here is plot the fatal outcomes. Plot. Okay, here's the thing. COVID. We're doing a subsetting. We're going to make a different. We're going to return a new data frame based on 2 logical arguments, okay? They have to be enclosed within parens like that. Okay, the first one is give me the outcomes that were fatal and logical and give me the ones that are marked as female, so we can look at that. Okay, we do that, we're gonna get way too much. 4,400 rows, okay? And your exercise, should you choose to do it, is to figure out the same thing for males. Okay? Not terribly difficult, but go for it. Okay, I think that's all I want to show. Actually, it's not. We're going to skip a couple of these. There's your solutions when you do the exercises. Do them now, do them later. Work on your skill. Try to work through it all. Let's show the tallies on the map. Okay, I'm going to walk you through this one so that we can spend a little more time doing the next. All right. Gosh, I'm drawing a blank here. I'm wondering why this is here. I tried to figure this out last night and I got myself a little confused. Okay, this is showing tallies generally on a map. Okay, sorry for all the motion. Okay, I'm going to run this. Okay, let's say we got a string. Okay, A0B1C2. I made it up. Okay, and we know that that's what we've got. Okay, that in our data set, we saw it earlier. I won't scroll back up because the moving is going to make you guys seasick. We don't want that. All we want to do our visualization is the FSA, okay, the first 3. Okay, so if I do this, my string, so my string is set to this string A0B space 1C2. If I say my string, which is iterable, give me a subset of it and show me 0 through to 3, okay, because that's 0. Okay, that's 1, that's 2, and the 4th one there is 3. Okay, and we know from subsetting that we want to show the 3 so that we get A0B, and we do. Run it again, A0B. That's what we want to show. Okay, so if we do COVID and we select the reporting PHU postal code, we know what that looks like, right? Let's just quickly split that cell, dump it in here and just show that. Okay, it's these, right? Now, by the way, while we're here, does anyone see the typo in this? There's a problem with this data. Can anyone spot it? Anyone see what's wrong with the data here? It's the first 3 and the 4th one. Chopping this off, right? All we want is the first 3 anyway. They seem to be okay. Okay, so how do we do that? Well, we know that there are string methods for that. One of the string methods is called slice. You can find it in the documentation. But Pandas has very conveniently given us a string object within it. The data frame knows what a string is. It's got a separate thing, and it knows how to slice. Okay, and it's all kind of baked into the syntax. So we can say slice, start at character 0 and stop at character 3. Okay, and then just show me the head. Okay, let's see what that looks like. I'm going to run it. Okay, and it does exactly what we would hope. Okay, and what it's done is it's chopped it off and returned that. Okay, so if now that we have the FSA, which is great, we need to tally it by the outcome. We want to really just plot, the ones that are resolved, for example. Okay, I'm going to run this to see what we get. Yeah, nothing's going to happen there. We need to run it anyway because outcomes needs to be assigned a value because we're about to use it here. Okay. Okay, so we're going to make a brand new data frame, FSA outcomes. We've already subsetted it. All we've got is the resolve. That's what we want, which is fine. So outcomes, give us the postal code, but whatever you get in there, slice it and give me only the first 3 letters. Okay, and then show me the value counts. Okay, what does that give us? We're going to find out. If I uncomment that, okay, now this might look very familiar. This is exactly the kind of data. M5B had 160,000 cases. N2J had 16,000 cases. It's 2 columns of data. It's a useful amount, for the sake of this demonstration. What's its type? It's a series. Great. Okay, that's what we want. Okay, so what we're going to do is make a brand new data frame. We're going to take this series, okay, and we're going to pass it to data frame. Okay, and data frame is going to take the series and create a data frame out of it, which we name DF FSA outcomes. Okay, I'm going to run this whole thing so you can see the result. Okay, it's now a data frame. It's not terribly useful at the moment, but it will be in a second. Okay, we are going to name the index P code because if you recall previously, there's another data frame we're going to join this to that has P code in it. We're going to name the column resolved and just show us the head. Okay, now we have something a little bit more meaningful. Okay, that's our index P code. That's the resolved column. We've got something we can work with now. Okay, let's go get Ontario. We don't have Ontario yet. We've loaded the Canada data. Or perhaps we haven't. Uh-oh, we don't have the Canada data. Okay, that's fine. I believe it's in here. Remember I talked about bugs? Here's a bug. Is it in here? Oh boy, oh boy. Let me grab it from, I'm pretty sure it's in this one. There's Canada there. Okay, I just want all of that. You're going to have to do this as well. So copy Canada. It's defined here in Viz prevalence, the last one. We're going to go back to cursory analysis, back to where we were, which is fine, and stick it at the top. I'm just going to split this here and dump it in there. Okay, and run it. Okay, now Canada exists, which is great. Back to where we were. Ontario is Canada. I figured this out for you. It's PRU 35. That's Canada. Great. We're going to extract it. We're going to print out the head. Okay, I'm going to insert a. I'm just going to split that there. Okay, just to show you what's in it. Okay. And so this is Canada. This isn't the data frame we just made. That's still up there. We're going to use it in a second. Okay, and now we have a new data frame from Canada that gives us the shapes for all the various FSAs in Ontario. And there are the FSAs right there, okay? It aligns really well with that. So we can join this data frame with that data frame. Okay, I'm going to do it here. It's thinking about it. Notice I've got, we're going to run plot bouquet again, same as we did before. Okay, it'll take some time because Ontario is also complex. Okay, and there it is. So we have plotted, resolved. See that there's a purple one there? If I hover over that, FSA, the postal code P0J had 203 resolved cases for this particular data set. Okay, I'm going to just using my scroll wheel to scroll up. You see how dense they get, and you're starting to see, you know, basically prevalence information plotted on a map. Now, these things are really chunky. If we get rid of this simplified shapes, again, if I do Command or Control / next to the right Shift key and Shift Enter to run it again. Get rid of that while we're waiting. We will see as soon as it's finished rendering. My computer is about 5 years old, maybe it's a little older than that actually. I think it's an Intel i5 processor. So it's not slow, right? But these things take a while. And the more data you give it, the more processing power it takes. I'm going to guess it does not use the GPU to figure things out. The user interface is a bit slow as well. Okay, but you can start to see all, it really aligns nicely. The FSAs align really nicely with the streets. Okay, and there's your 160,000 resolved cases for the downtown Toronto, which is a lot. You can see that somehow sometimes the mapping doesn't really align very well. It's like, I don't know, these features here aren't really included. Okay. So all of that code you saw there, it's been summarized here. This is the sum total of what you need, excluding importing the data. Okay, so this is just the summary of all those steps. I broke it down and we looked at loading a data frame, loading another data frame, subsetting a data frame, cleaning a bit of the data because the postal code wasn't acceptable. We needed to turn it into an FSA, which we did. And we then joined that data to another data set and then plotted both on a map. Okay. There's a couple of options here. The color map used to highlight is a spectral highlight. You can see it here. It looks like a rainbow. Not ideal for use in visualization. You don't always want to show high numbers to be read, but this is the default and I've kept it there for you guys. This visualization, once you've scrolled and stuff, you can use these tools. I believe you can export it. There are tools in there for that. There it is. It's just dumped a PNG file of what we're looking at. So if you want to use this data somehow in a report, it's not that difficult to make that happen. Okay. Again, all the code is here. The exercise for this one is do the same thing, but plot a tally of the fatal outcomes. Okay. I have a funny feeling that what I just showed you here was supposed to be shown in the very last visualized prevalence. Let's have a quick look at that to see if I've missed anything. And if I haven't, that's fine too. You can go ahead and work on the exercises. And then we can call it a day. Okay, it looks like I've got a little bit more detail here, which is good. Clearly that needs a little bit of work. Okay, so, right, okay, so if you're doing the exercise on this, switch over to Viz Prevalence, if you please. I'm just gonna run that one now. You gotta load all of this stuff. Switch over to Viz Prevalence and we'll spend the remaining 10-15 minutes, you guys working on this exercise. Okay, I'm just gonna start running these. Shift Enter all the way down. Okay. Yeah, put that in there. Okay, that's where it should be. I'm gonna run that one. Not all of them need to be run. Let's see if we're getting the same kind of results with a little bit more explanation in this one. So there's some tidy up to do, a couple of bugs to work out. But the good thing is that once this is all done, work through this. Okay. Plot the map. This will work now. Okay, and there it is. Just to speed things up, we're showing it chunky. Simplify shapes is set to 20,000 kilometers is what that means. 20,000 kilometers. Okay, and it shows you a chunky map. Once you've got what you want, you can turn up the quality and off you go. Okay, so there's your summary code. We know that it works. You can click the little bars here to collapse them, okay? So let's spend the next little while. This is the summary code for showing the result. Let's see if you can get it working to show the fatal outcomes instead. Okay, and we'll do that for about 10 minutes. Please turn your mic on and talk with me if you get stuck or have any questions or want to chat about something around here. You can set color maps completely manually, or you can use predefined palettes. All right. So I was just messing around to see what I can come up with. But yeah, lots and lots to do in this sort of thing. So that's it for the notebooks. We are going to spend the next couple of minutes. We'll have maybe a bit of chat afterwards. I'd like to know your impressions on if you're going to attempt to learn a bit more about Python or not. But for the meantime, let's summarize. So I've given handling large data. There's basically I've given you a cheat sheet here. We talked about getting information using the info method. You can print an entire data frame, even if it's millions, and you don't grind your computer to a halt. The shape will return the number of rows and columns very quickly. That's a typo. Shape is not a method. You can do head and tail just to get a quick glance at the first few or last few rows. You can subset it. You can subset it according to, you can use logical values to exclude certain rows. You can filter them, okay, and things like that. Okay, and if you're using more than one condition, don't forget each condition needs to be wrapped in parens. Nothing to do with PEDMAS, it's just the convention that the data frame needs. And you can do things like sorting and so on and so forth. If you go and look at the Pandas documentation for data frame, there's pages and pages of options and methods. So you'll learn as you go. Okay, you can do geographic plotting. We demonstrated that. We looked at some epidemiological data with postcodes. We got data from 2 different sources. We combined it and showed it on an interactive map that automatically pulls in street maps and other geographical features, all with, what's this? This is like a dozen lines of code, none of which you really fully need to understand. This is useful stuff, isn't it? We talked briefly about data cleaning, very, very briefly. We didn't even attempt to clean the L that showed up in some of the postal codes, the L that should have been a 1. That could also be cleaned separately, but we didn't need to, we just chopped it off. There's another saying in Python called Yagni, Y-A-G-N-I, you ain't gonna need it. So don't spend effort cleaning the L if you're gonna discard it in the next step. Okay, and we demonstrated you can show prevalence tallies on a map. So I guess overall, my advice to all of you is to get used to using a tool like this, whether it's R, whether it's Python, but branch out away from sticking to predefined packages that do what you need them to do. Think of this little guy here on his scale, okay? Your need for a custom solution couldn't be easily done with something like Excel. I know Excel has a macro language, but please don't use it. It is so horrible. It makes your eyes bleed. It's not worth it. If you work with data, work programmatically. Learn how to drop down from the one level of abstraction below that's your comfort zone. Okay, and you'll find you can do things like build a tree to weigh a koala. Also, Jupyter Lab, very useful tool, far easier using Python in snippets to make notes and stuff like that. If you've used any other notebook software, same deal applies. They are great for doing the kind of work that we do. And with that, I'm going to wrap it up.